Hi class, let's take a look at example 2. Now in example 2 they want us to do a probability distribution, and what they're referring to is a simple table where we can actually organize the probabilities. So we're looking at a table in this format, and they do tell us which x values they want us to do, so all the way to 5. And for any probability distribution, we would have to put in a title. So let me just put in a title, Poisson event. And then the first column is going to consist of your x's. So technically 0, 1, 2, 3, 4, and we're going to go all the way to 5. And then we're going to be evaluating each of these. So the numerical value that goes here is going to represent the probability of x is equal to 0, followed by the probability of x is equal to 1, followed by x is equal to 2, and technically all the way to x is equal to 3, probability of x is equal to 4, and we are stopping at 5. So the probability of x is equal to 5. They do have to tell us where to stop. Poisson events are going to have large values for some of these, and technically they could be going on all the way to a large value of n. So they will have to tell us where to stop. They wouldn't ask for a lot of values. And since we're evaluating specific numerical values, these are going to be the PDFs. CDF we're using if it's the sum of multiple of these on a less than or equal statement. So let me just run the first one. And in this case, we're just going to be doing the Poisson PDF. Now, the event is stating to use mu is equal to 5. So in this case, actually 0.5. So it's 0.5. So 0.5 comma, and then the first success is 0. So that's going to give us 0.6065. So this will be a 0.6065, rounding to 4 decimal places. Let me run it again. And then in this case, I'm just going to modify the 0 to 1. And I'm getting 0.3033. And then in the same format, we're just going to keep evaluating all the values. So we're looking at 0.5 comma, and then we're going to evaluate 2. For this one, I'm getting 0.758. So 0.0758. I put in the code for all the evaluations down here on this handout so that you can check them. You're always punching in technically the values of mu and then comma by the x's. Some of your calculators, they may be calling mu the same value as lambda. So just something to take into account because they may do that. And let me just fill in the rest of the values. So for 3, we're looking at 0.0126. Then the values of 4, 0.0016, rounding to 4. So 0.0016. And then the last one, let me write the decimal approximation. So it's using, so this one's going to be on scientific notation 1.58. I'm running to 2 visible there, times 10 to the negative 4. So this is going to be approximately 0.00 1 extra 0, 1, and then we're looking at a 58. And in this case, the values of 1.58, it as a decimal, you're just moving the decimal to the left. So 0.0000158. This is a 5. and then you're just moving it, in this case, to the right to double check that we added enough zeros. 1, 2, 3, and 4. Okay, so we're good. It's 3 zeros and then the 158. And that's actually it for the probability distribution. What they're actually asking us to do here is to organize the successes of the event, because from here you can actually come up with a bar graph or any of the other graphs, some sort of a pie chart as well. That could be a possibility. But for any regular probability distribution, they're just referring the table with the probabilities, where we're putting the successes, in this case the x's, and they have to tell us where to stop, and then the probabilities associated with them. All of these for the probability distributions, we're going to be using the PDF. Remember, CDF is for addition. So that's actually it for this problem.